Hey, it's Mrs. Mart here. Unit 4, Lesson 16, Practice Problems. It says the revenues of two companies can be modeled with the exponential functions f and g. Here are the graphs of the two functions. In each function, the revenue is in thousands of dollars and time t is measured in years. So we have revenue in thousands of dollars on the vertical axis and time in years on the horizontal axis. The y-coordinate of the intersection is 215.7. All right, so if we look at that point of intersection, carried over, it's at 215.7, the y-coordinate. Select all statements that correctly describe what the two graphs reveal about the revenues. So first, the intersection of the graphs tells us when the revenues of the two companies grow by the same factor. No, it tells us when they have the same amount of revenue. So I would not select A, but I would select B. The intersection tells us when the two companies have the same revenue. At the intersection, f of t is greater than g of t. No, that's not true. They are the same at the intersection. At the intersection, f of t is equal to 215.7 and g of t is equal to 215.7. Yes, that's true. Because in function notation, this number here is the output, and the output is what we see on the y-axis. So yes for D. E. We need to know both expressions that define f and g to find the value of t at the intersection. If we had to solve an equation, we would need that information. But on a graph, you can find that information by determining the x value of the coordinate, okay? And then finally, f. If we know at least one of the expressions that define f and g, we can calculate the value of t at the intersection. Absolutely, because if you know the expression for f, you can set it equal to 215.7 and solve. And same with if you know the expression for g, you could set it to 215.7 and solve, because at that point, those functions have the same input and output. Okay, so B, D, and F. All right, number 2. The population of a fast-growing city in Texas can be modeled with the equation P of t equals 82 times e to the 0.078 t. The population of a fast-growing city in Tennessee can be modeled with Q of t equals 132 times e to the 0.047 t. In both equations, t represents the years since 2016, so that's on the horizontal axis, and the population is measured in thousands. So we see on the vertical axis population in thousands. The graph representing the two functions are shown. The point where the two graphs intersect has a y-coordinate of 271.7. So that's the y-coordinate. What does that intersection mean in this situation? It means the year which both cities have the same population. Find the x-coordinate of the intersection point by solving each equation. Show your reasoning. So for function p, we're going to solve 82 times e to the 0.078t equals 271.7, because that is the y-coordinate. at the point of intersection. And for the second city, for the city in Tennessee, we're going to solve 132. So from this equation, times e to the 0.047t equals the same number because they're the same, 271.7. Okay, so our first step is on here, divide by the 82, and that gives us e to the 0.078t equals 271.7 divided by 82. 271.7 divided by 82 is approximately 3.31. And so what I know, I'm going to have to move my work up here. I'm going to switch this to logarithm form using natural log since the base is e. So I know 0.078t is equal to the natural log of the 3.31. Okay, so I'm going to find that natural log and then divide it by 0.078. So to get the most accurate response, I'm going to just have the calculator use the answer from before. And then I have to divide it by 0.078. And so t is about 15.359 if I round to the 3 decimal places. 359. Okay? So that's for the town in Texas. And then the town in Tennessee follow the same steps, divide by 132. And so e to the 0.047t is equal to 271.7 divided by 132, approximately 2.06. But then again, I'm going to use the natural log since the base is e, so 0.047t equals the natural log of 2.06. But when I put it in the calculator, I'm going to have it do the natural log of the above answer. And then divide that by 0.047. And I get almost exactly the same answer as I did up here, 15.359 again. Okay, so I would expect to get the same answer since I'm solving for the x value in this point right here. So it looks like it's 15.359 and then 271.7. Okay, and then finally, explain why we can find out the t value at the intersection of the two graphs by solving p of t is equal to q of t. So at that point, so p of t and q of t, these both represent outputs, but when they intersect, their input and their output are exactly the same. So like they both have the same input, they both have the same output. That's what it means to intersect. And so if we were to solve 82 times e to the 0.078t equals 132 times e to the 0.047t, we can solve for the input that way as well. Or we could graph each one and see where they cross, which has been done up above. So to solve this, we did this in the lesson summary today. And then I would also divide both sides by the e over here. And so what we get is, okay, this is kind of hard to explain, but when you divide powers with the same base, you subtract their exponents, right? When you divide powers with the same base, you subtract their exponent. So the exponent here is going to be 0.047 minus 0.078. Oh goodness, I'm in the wrong screen, sorry. Okay, 0.047 minus 0.078. It's going to be a negative number, that's okay. So what I have is e to the negative 0.031 t is equal to 82 over 132. I'm just going to leave it as a fraction, makes it easier. And then finally, convert that to log using natural log since the base is e. The natural log of 82 over 132. Okay, so find the natural log of 82 divided by 132, and then divide that answer by the negative 0.031. Negative 0.031. And we get, look at that, 15.35. This would round to 8. So almost exactly what we've gotten on the other two. So this would actually be the closest to the exact answer. Okay, so my guess is on the graph itself, this 271.7 actually had some more decimals after it, which would be the reason for the differences in the answers. But there you go. I would guess that you might at this point in time prefer using the graph. It's a little less tedious than actually solving the equation. Okay, so next, the function f is given by f of x equals 100 times 3 to the x. Select all equations whose graph meets the graph of f for a positive value of x. All right, let's do that. Let's go ahead and I'm going to go back to Desmos. And I'm going to first put in 100 times 3 to the x. And then after that, I might make my windows go like only positive values, like maybe 0 to 10, and then 0 to maybe, I don't know, 1,000. Okay, so that's the first one. And then 10 times e to the x, 10, and then times e to the x, oops, not to the y, to the x. All right, so you can see that they're going to meet back here where it's negative, so not that one. So let's try 500, and then times e to the x. Okay, they also are going to cross back here where they're closer and closer together, so not b. And then what about 500 times e to the negative x? Ooh, they cross right here in a positive area, so I'll go ahead and circle C. And then, okay, the last two, 1,000. Oopsies, that's not what I meant to do. There we go. 1,000, and then times 2 to the x. Okay, they're going to cross back here. They're getting closer and closer back in this direction, so not D. And then 600 times 10 to the x. And they're clearly crossing back here, negative value. So it looks like it's just C. Okay, number 4, the half-life of nickel 63 is 100 years. A student says an artifact with nickel 63 in it will lose a quarter of that substance in 50 years. So we'll lose a quarter of that substance. So they're saying lose 25%, which means it would be changing by a factor of 75%. Okay, so do we agree with the statement? So a half-life of 100 years. In 1 year, the decay would be 1/2 to the 1 over 100, right? For 1 year. But for 50 years, it would be 1/2 to the 50 over 100, or you could say 1/2 to the 1/2, since 50 over 100 is equal to 1/2. So if we evaluate 1/2 to the 1/2, so 1/2 to the 1/2, I get about 0.71. Okay, oops. So about 0.71, which, I mean, his estimate is close, but it's not accurate. So if the factor here is 71%, then 20, no, so this is what would remain, 29% would be lost. Okay, because, 100 minus 71 equals 29. So this is the percent retained. This would be the percent then lost. So he was close, but not quite. Okay, all right, so the log, we're going to do some estimates, and then we're going to do some actual values in the calculator. So I know this is base 10, right? And so I know that 123, okay, well 10 squared is 100. This is more than 100, but it's less than 10 to the third. So I'm going to say between 2 and 3. And then this would be base 10. Okay, so if this was just 100,000, it would be 5, but it's a little more than 100,000, so it's going to be between 5 and 6. And for the last one, also base 10, let's see here, to the 0 would be 1, but then to the first would be 10. So it would be between 0 and 1. Okay, and then to use the calculator, we're just going to use the log button. So the log of 123 is about 2.09. The log of 110,000, 5.041. And the log of 1.1, 0.41, or 0.041. So it looks like the estimates are accurate. This is more than 2 but less than 3, more than 5 but less than 6, more than 0 but less than 1. Okay, 2 more problems. We're almost done. Number 6. So basically on number 6, we have 2 functions. F of x equals 100 times 1.2 to the x, so that shows 20% growth. And g of x is equal to 100 times e to the 0.2x. So this shows also 20%, but continuous growth. So since they're both growing by 20%, graph 2 is going to be function g, because continuous growth will grow faster, slightly faster, and that means that graph f, or function f, corresponds to graph 1. And then finally, here's a graph that represents f of x equals e to the x. So the solution to, how can you use the graph to estimate the solution? So we would look at the graph, we would look for 300 as an output and see what the input is. So 300 as the output, here's where it hits the graph. So the input is right there somewhere between 5 and 6. And then the value of the natural log of 700. So just keep in mind, the natural log of 700 is the solution to the equation e to the x equals 700. And so we would do the same thing. Find the output of 700, here it is, follow it over to the graph, and then see what the input is somewhere between 6 and 7. Okay? All right, so that is the end of your assignment. I hope it was helpful.